Ladies and gentlemen, welcome to our talk, 50,000 lines of code for a cup of coffee. We're both very happy to be here. We're very proud to present you our project, and we're really happy that you choose out of all the possible presentation hours. So we'll try to entertain you for the next half an hour or so. We talk about 50,000 lines of code. It was a very interesting, innovative project, and first of all, we want to show you why do we choose the title. Obviously, as a reference to Jules Verne, 20,000 Leagues Under the Sea. And if you know the book, it was a great struggle. It was an epic struggle under the sea, 20,000 miles. And that's also how we feel in the project. We had to overcome all kind of different difficulties, challenges, and everything. We'll talk about it in a minute. And so that's like why we did it. And also because Jules Verne was such a technological innovator. And so the reference to him, 20,000 Leagues Under the Sea. More important, but if you see this like striking discrepancy between like a cup of coffee and 50,000 lines of code. 50,000 lines of code, it's not massive, it's not huge, but it's still like a substantial amount of code. And on the other hand, you have a cup of coffee that seems to be like such an anachronistic thing. You know, a cup of coffee, you have like water, you have beans, you have steam, you have energy, and that's it. And on the other hand, you have 50,000 lines of code that seems to be a little bit over the top. On the other hand, we talk so much about IoT devices, IoT things that will come up, projects that will come up. And so all of these projects, all of those devices intend to make our life more valuable. In this specific case, we have a coffee that will be more individualized. It will be more up to your taste. It will be exactly have the milliliters of what you want to actually drink in this specific mood. And in comparison to that, 50,000 lines of code is basically nothing. So this is where we are, 50,000 lines of code. We'll show to you lessons learned, challenges that we overcame, challenges that we're still struggling with, and also without like going too far and without like spoiling anything, we have like two important things here. First of all, IoT is kind of like hot right now and it's interesting right now. It will be old in a commodity in no time. You know, if you look back to like a few years back about apps, a few more years back about like websites, they were hip, they were great at that time. Today they're just like commodity. So also IoT will be commodity. And if I talk to you as developers, you will have like a tons of IoT projects in the future, and it will just be like one thing just as the other ones. And therefore also like how much is new. If I like right there, it's like new IoT, all new coffee machine, all new. I'm not sure. You will find that there's a lot of stuff that you already know. I mean, it's about coding, it's about testing, it's about integration. And then there's that little part, and therefore the little new about all the challenges that we like faced. And Michael will start with the product introduction.
So the client came to us and said, we want to start a project with you. There's this machine, and it's a coffee machine, and it's a really amazing coffee machine. It's a pure black liquid joy coming out, and it can do cold drinks, it can do hot drinks, and you can adjust everything you want, and it does really, really nice frothing. But that's not it, because there are many machines like that. The machine will be connected, so you're not tied to the crappy displays on the machine and the buttons that are on there. No, you will have an app, and you can configure your drink, your recipe, exactly the way you want it. So you can take your favorite mug and adjust the drink size so it's perfectly filled. You have the exact amount of frothing you want and the exact amount of milk you want, and so you can have it always with you. And if you have your recipes on your phone, you can also go to a friend's house that has the same coffee machine, or to a shop where you buy the capsules, and you don't have to configure it again, right? You just get out your phone, you press a button, and you have exactly the coffee you want. Sounds interesting. And the machine will be connected to other services, right? So the machine will talk to services in the background, and the app will talk to the services in the background. And so if you want to change your phone, well, all your data is already in the backend service, and you just can, log in again, and you have all your stuff there. If you want more capsules, if you need a cleaning set, right, you just press a button on the machine or on the app, and you will get your cleaning set. My colleague Matt Henschel, he spends quite a bit of his time thinking about smart ecosystems and connected devices, and he came up with those layers, how you can structure and think about connected devices and the ecosystems around that. And these layers apply to our project as well. So you start with a product, and the product has certain core functionalities. In this case, it brews coffee. And then you put some more logic into it. You make it a smart product, which is usually in the firmware. So you write a piece of code, and you put it onto that, and all of a sudden this dumb thing, this product, became a smart product. The next step is you connect it. You connect it with devices. This machine does not usually talk to it. This can be an app, this can be the internet, but all of a sudden your whole ecosystem is already a connected product. And for us, the last step was to have those services in the background, and then you call it a product system. And this is where at least our project ends. If you ask Matt, he will draw another circle around it, and he will say the next step would be a multi-layered ecosystem, which in this case would mean there's not only a coffee machine talking to the internet and talking to an app, there's a fridge and an oven, and they are connected on all different layers. So they talk directly to each other, but also to the layers on top. So in our case, let's be a bit more specific. Well, we had this machine. Honestly, we did not build the hardware. We are not good at that at ThoughtWorks. Not yet, I don't know. So there was a hardware company that actually built the bits and pieces for that. And this was the company actually that also built the firmware on top of it. So this is probably written in some dialect of C. We did not write that either, but obviously we were talking to them constantly and working very closely with them. So our part actually began where things get connected. So we built an iOS app, we built an Android app. Obviously, if you have a connected coffee machine, you need a watch app. And we built the backend services, the website, and the shop behind that. For this talk, I want to make it a bit more simpler, because otherwise I would get lost in details all the time. So for this talk, we want to focus on those three components: the machine, the app, whatever platform that is, and the backend, just to visualize a few of the examples. And after we understood what the project was about, everyone was really excited about it, because it was like, yeah, this sounds cool. We want to build this, right? So we were like, okay, just give us 2 or 3 prototypes of the machine, and then we can start right away. And then the client was like, fun fact. There is no machine. You know, the project will go on for a few months and a year. So at some point you might receive a prototype, but we don't really know when, and we don't really know what this thing then will actually do. So we started basically, well, with an empty editor and an empty IDE and a goal to brew coffee.
And there was basically our first challenge, prototyping, because if Michael says there was a fun fact to have no machine, but there was actually the reality for us. And it's actually a weird challenge, because first of all, if you don't have a test device, you cannot test. I mean, obviously. But also, we are software developers, we're just not used to having like any hardware struggles. Normally the hardware that we need for our project, we can just buy, we can like have, we can like acquire, we can, I don't know. It's not like really a big problem. So in this specific case, we did not have a prototype. And that really became like an interesting part. And so it's interesting if you look first of all on like how we normally develop software, then to compare to, like in this case was the hardware development. Even in big projects, or especially in big projects, we might have like in the beginning a click dummy that is not really working software. We can just like click on it, the customer gets like a certain impression. You can make like certain whatever app front end stuff, but at the end it's just like a little thing. And from then you basically have working software from the beginning. however you want to call it, if it's like the alpha or the beta, if it's the release or whatever, you always work with working software. This is what we do in our incremental approach. So in whichever direction you want to go, you add some more, It's like better, nicer. But you could also interrupt the project at any point of time, and you have like some kind of a product. So this is how we do it, and we can actually pull this off in a small amount of time. I mean, whatever you want to call it, is it like weeks, is it days, is it hours? But like working software is something that we get frequently and like really easily used to. It's very different when you talk about hardware development, and then we come to our different prototypes. The first step is also some kind of a dummy. It's not a click dummy in this specific case. It's a little bit blurry as I see from here, but it's a styrofoam. It's a styrofoam machine. That was like the first idea that we had. That was the customer gave us. This is a block of styrofoam. Has no functionality, nothing inside except for styrofoam. So what we did, we like pinned some displays on top of it. We had this one guy at the customer who actually made sounds to this. I don't know exactly why, but he made like, this is a button. So all kind of these things, we circled some buttons on top, but it was like very premature, and we couldn't do really much with it. Nevertheless, and there was like showed in like the different prototypes I will show right now, it always served a certain purpose. So very first idea, our 3D styrofoam coffee machine. We started developing, and we quickly realized that we needed like some kind of a counterpart. And obviously there was no coffee machine as the counterpart, so we developed that fake service. The thing that you actually see there, that is actually the prototype of the display as it was supposed to look like. So we felt almost like making the UI, we could have made it in any kind of way, making the UI in this way, it almost looked like it's having like a piece of the machine. At least the display. So what we were able to do this is like when we like sent some information from our kind of like fake app to the fake service, then we got like a fake response, and we felt like at least like there was like some kind of connection in it. There was like our second wave prototype, and we quickly realized that this is just not enough, because you can only go so far, and we came into like deeper functionality, and not a big surprise, we came to connections, because it's all about connected devices. So we developed that thing. It's a beagle bone. It was called our fake machine, also like sometimes called our emulator. And what we were able to do with this was not only to get responses, but also to have like a Wi-Fi connection, to establish a Wi-Fi connection, to look like at different scenarios with the Wi-Fi connection. And so this was for like a long time, that was the closest that we have to a coffee machine. And it doesn't resemble very much to the coffee machine, but it was very dear to our hearts. Before, and we like evolved here from prototype to prototype, we got this. And that already looks very much like a coffee machine, as you all would agree. It already has all the buttons. It's a little bit blurry. I don't know exactly why. It has already the display that you just saw before. The display also we like in the one version like stuck onto the styrofoam. It has the different buttons, and what you actually could do, you could basically do everything. I mean, that is at least what you assume to do, because for us, you don't need the coffee machine of the coffee machine, but we kind of like just needed like the interaction electronics part all around. So we had this thing, and it turned out that a lot of stuff that we developed did not work with this real coffee machine, with the real hardware, with the real Wi-Fi module. But we were really happy about it, because once we had integrated with the box, we thought like, so now if the real machine comes, and I can show you the machine, not because it's not out, and therefore I just have to hide it under this blanket. That is actually the real machine, and when we got it, the very first machine, it turned out there were even more problems. Now there was like an interaction with like heat and with all kinds of like different fields that occurred. So it turns out that like every step when we tested, we tried to have like a prototype that was as close as possible to what we just needed at that point of time, but it was never enough. And it turned out that the next evolution step was like we kind of like had to start from scratch. But still, this is the coffee machine, and we were able to integrate it. By the way, that is the coffee machine that we made the first coffee with. and it was a really interesting experience. It was very emotional, as you probably can imagine, and it turned out that it made out of like clear, crystal clear, yummy water. It made like kind of like a stinky, dirty kind of a liquid. But that's on the side, you know. The coffee at the end were really nice. If you look, those two scenarios that are just like portrayed to each other. In the top you have the software, in the bottom you have the hardware. You see that it's like different, first of all, in terms of time scale, because as I said before, you can pull off a software or a change in software or a bug fix or a next release in, I don't want to say no time, but like sometimes in hours or in weeks or like maybe in months. Whereas in the hardware, the development from the dummy until the first functional prototype took at least a year and a half. And that is also interesting for us, because it means for us that the software has to follow the hardware. If at the end we had a functional prototype that did not work as was specified or as we had anticipated that it would work, there is no way that there was a change to the hardware was being made. All the changes had to be made to the software. Also interesting is that if you look at this, you have like the software, the fake software part is really small. The real hardware stuff is also really small. So basically in the entire middle part of the project, so like the vast majority of the project, like cut off like a few weeks in the beginning, cut off like 2 months here at the end, was always done with like real software against prototypes that were not real. And there was an interesting combination that caused us all kinds of problems. We'll get back to this, but it was also really interesting. It was especially interesting when it comes to testing, because we had to be really innovative with testing, and Michael will talk about that.
Let's talk about testing in this project. I'm assuming everyone in this room does automatic testing every day, all the time, and we're basically used to it. It gives us a safety net, and we always aim for this pyramid. Tons of unit tests in the bottom to, you know, check all the corner cases and the bits and pieces. A few integration tests to see if all the small components work together, and some end-to-end tests on the very top to make sure everything is tied together smoothly and plumbed together. And for us, well, for each individual component of the system, you can do this, right? So do a test pyramid. For backend services, this is business as usual for us. We have all the tools, we know everything, we know how this works. For the app, to be honest, there might be people that have more knowledge around this than me, but this was already a bit tricky, right? UI testing for iOS back then, where there was no UI framework, that was already tedious. And for the machine, well, first of all, we did not really build a firmware for that, but we could not test it at all. But even if you do all the testing pyramids for all the components, how do you make sure that they actually work nicely together? And so the first problem we had, how do you test the integration with something that doesn't exist? So we said together, like, okay, there's no machine, and we want to test something, and we want to build new features, and this is just not there. But to be honest, this happens in real life too, right? Sometimes you have upstream service that does not exist. Usually what we do is contract testing then for this. And we kind of applied a version to that as well. So we started off with, well, the situation is I want to have a new feature, let's say on my app, and this feature is not supported because there's no machine. So what we then did is we wrote a test against, well, nothing for now, but so we made a red test that is just assuming this feature is working. I can send a recipe to the machine, or I can configure some stuff for the machine. And then we took the fake service, or later on the fake machine, and we implemented this feature on that side. So you have a contract test that is now green because some fake system does what the test is testing. And guess what? So far at this stage, you're not building any software right now that's production code. You just wrote 2 components to set up like a harness for what you're expecting later on. So then we could use this feature with our fake service, and we could start developing the real production code for the app. And at some point when we then got the box or the real prototype of the machine, we could run all the contract tests against what we just got. And when we got a new firmware version, we could then rerun all the tests. And guess what? It was never green the first time around, never ever. But at least, even though the iteration cycle for us was very long until we received something new, we could at least give feedback right away, and we could, put our finger onto one test and say, here we expecting something else. The machine is not behaving the way we expected it. And we could start a discussion. And at the end, then we received an update for the firmware, and then we could really use this feature together with the prototype. So there's a lot of indirection. There's a lot of work you do upfront. There's lots of test code that is not production code, but at least you can get around with that. The downside to this approach is that we ended up using corner cases on a very high level, on the integration level between one component of the system and another one. So we were checking HTTP statuses on that level. And we were, all the, as I said, corner cases. And this is something you would usually test on the layer down, hopefully on the unit test level. So we ended up with lots of tests like that. But at least it was one approach. How do you fake physical user interaction? So one rule with this machine was it will only spit out coffee if you push a button, because you have to make sure that there's a cup under the machine. You don't want to play around with your phone and flood your kitchen at the same time. And then we wrote tests for that, and we thought, how can we make a user push a button once we have the real machine? And we actually thought about buying a Lego Mindstorm set and just, have a robot finger pushing the button. But then it turned out that the button was not a push button, but it was a jog dial, and so we threw this out. What we then did is we just assumed in the test that we could do it. So when we wrote a test, we set up some stuff, and then the action user presses the brew button, and then we assert some other things. And the implementation of this call was, well, it was an interface, and we had two different implementations of that interface. One was a fake one we would use with our service, with our fake machine and fake service, and this would then look like this. You would just call a URL. Machine, fake actions, click brew, and then you get a 200 back. And this was our automatic way of faking that somebody pressed the brew button. How does this look like when there's the real machine? At first it sounded stupid, but we just showed a message. Go over to the machine and click the brew button. Or later on, where there were more sophisticated tests, go to the machine, read what's on the display, and type in what you see on the display. And obviously, well, we didn't then fully automate all the tests, but we moved on from a set of automated tests to what we then coined as guided manual tests. And when we got a new firmware version and we would run all the tests, then this person could start the things, wait for the pop-up, see what the pop-up asks you to do, go to the machine, do it, and come back. This sounds very tedious, and to some point it was. But on the other hand, we would always run the same set of tests we ran before against the fake machine, against the real machine. And so, except for this little thing, this little user interaction, the tests were the same. So 90% the same test. If you've got better ideas for this, please come to us after the talk, because this was the best we ended up with. Setting up scenarios for end-to-end tests. So we had all the three components, and I don't know what your experience is, but if you have two components and you have to set the upstream system up for a certain scenario you want to test, this can easily become quite tedious already. For us, we had then an extra thing, a third thing. So if you wanted to test end-to-end one part in the app, you have to set up the backend system to a certain situation. You have to set up your fake machine to a certain situation, so you can run an end-to-end test that actually integrates all the components. And honestly, we horribly failed on that. It became so complex and so hard to write. So we were just, in the end, we were just splitting the user journeys. Right? So we just said, okay, let's look at the whole flow. Let's look from an analysis side and then cut it so that we can test the whole user journey, maybe with 2 or 3 tests, but each test should just involve the 2 components. And yeah, you can now argue, well, this is not an end-to-end test, right? It's not 100% coverage or whatever. But on the other hand, testing is about giving you enough confidence, right? And the effort you have to put into that. And on the other hand, the confidence you get from this. This was our balance. And it made the test at least doable. So those 3 methods, contract tests, fake, guided user interaction, and those partial user journeys gave us the opportunity to at least handle the complexity of the situation. And to be honest, on the next project, I would try those same things again and come up with more stuff.
But even more interesting, or like at the core is, I don't know if you got this entire part here, we're talking about IoT, about connected devices. So obviously making connections is like really at the key of our project. So what we actually did is we imagined like our setup here, as Michael described already, and said like, okay, now since all the things are connected, now imagine like what kind of features we can do, what kind of settings we can do, what are the recipes, what are like the different coffees, how can we connect it to Facebook, how we can like share recipes, how we can transport them throughout the world and whatever. And we came up with like something that was like more complicated than we actually thought. Just like to give you like a tiny little bit of impression, like just imagine you have like a person, like one of you comes, like I just imagine like you're like so curious right now, you will buy this machine. You go to the machine, you want to brew a coffee. The coffee machine thinks like, well, I first have to clean. So it sends a message back to the backend. Says like, backend, please tell the app that I need like a cleaning. So message to the app, please make a display, machine has to be cleaned. So then the information goes to the same guy again, clicks on the like, please clean the machine, information to the machine, and then back. So maybe there was a little bit fast, maybe that's not like 100% accurate, but it shows how complicated these user flows are, even if you just like press the button, please make a coffee for me. And there was definitely really a challenge for us to see like to cross all these boundaries and to make like the tests and the testings and the integration and the orchestration of all the different things. And I can tell you, it works different with all the different prototypes that we had. Even more interesting, but was that we focused on that. We said like, okay, everything is connected. And at one point we realized, well, first of all, we have to get these things connected. And it seems to be such a logical step, but we somehow like did not really think about it because we were like so excited about the connected devices. And then we started thinking about like connection of devices. Because you can't just buy this machine. You can just buy it, you can unwrap it, you can connect it to your outlet. You have a machine sitting at home and you can use it as you can use any other coffee machine. You can put in your capsule, you can put in your milk, you can choose one of the recipes that are predetermined, pre-set up on the coffee machine. You can just make a coffee as with any other coffee machine. And that's fine, and that's like accepted, and there's like no punishment or anything for this. You could also use your app, you can download, or you can use your phone, you can download the app, you can use basically your phone as a remote control. You can make your individual recipes, you can carry them around, you can make your coffee at home. Or you have the full setup, the full beauty of this entire device with the back end, with the integration to all kinds of other devices. So, and just to see, or just like to illustrate how complicated it is to make the setup is, once you connect the machine to the outlet, you buy it, you unwrap it, you put it on your counter space, you connect it to the outlet, it works as a hotspot. So then you can disconnect your phone from your Wi-Fi, can connect it to the machine hotspot. You can then transfer the credentials of the Wi-Fi that you've just connected with from the phone to your coffee machine. The coffee machine can then disconnect, can then switch from hotspot mode into Wi-Fi mode, can connect to the Wi-Fi, and then the phone can also. It's a long process, and it was really interesting to figure out through all the different processes. So in retrospect, we say just to get the machines connected took us about half of our work. And that really sounds a lot, and that is a lot. Because what we actually wanted to do was focusing on functional requirements from the customers, but actually what we did was to a large degree just to get things connected. And then also to make sure that it works for all the 3 different scenarios. It should always work if I just have like the app connected to the phone or in any other connection. Even more, what is if all of a sudden one of those is offline? And then you have like, let's say you have the machine is connected to the backend, but not to the app. The app is just we're now switched off or like disconnected. Or you send a pull request and it goes to the backend, but not to the backend, so we're not connected to the machine. Again, next corner case. And you have like always like those three things, and you can just see at what point you have to buffer which information, in which order they are sent to the backend once the network is back on. What if the backend is on but not the machine is on? Which direction is it? What is if you have contradiction information that are both buffered but now have to be sent in like different orders? It was a total mess. It was interesting, but it was also a total mess. And our lessons learned from this is don't underestimate that you have to get things connected, because it's all about connected devices, and if you cannot connect those devices, you just have an ordinary boring coffee machine.
Let's talk about security. So how do I approach security in my team? Honestly, well, first, with education, you go here to a conference and you see the security and privacy track. We write automated tests, so at least the things we are thinking about are working the way expected. We configure and provision our servers automatically, so nobody forgets to turn on the IP table service again. So, but is there more to that? I don't know. But if I would ask now every person in this room, do you feel that your application you're building is secure? I'm sure 95% will say, yeah, kind of. I don't know. But on the other hand, we're developing things every day and we're releasing them and we're deploying them. So it seems that in general, we are okay pushing stuff out into the wild. So we are okay developing software. And we all have our jobs. So it's not as bad, right? However, on this project, we were not comfortable at all, because we were like, there's this machine and somebody has this machine in their kitchen and they have all the time in the world and they have a screwdriver and they can just open it, right? And read out the memory and just, reverse engineer what is on the machine. So for every single feature we discussed, there were endless discussions around this. And most of them there were sentences like, but what if somebody does this and that? Or do you know that you can do this and that? So it seems like we went on to discussions again and again and again. And this got a bit out of hand. So we did something called a threat modeling workshop. And if you followed, you just spoke about it, right? The talk was earlier, so sorry, I can't now relate to that. But it's basically a guided, facilitated discussions around different topics of security. And Microsoft pushed out a card game that's called the Elevation of Privilege that helps you to do this. It's basically just ask different questions around that. And we did a couple of sessions with this, and there were many outcomes, but I want to show one right now. It was we came up with security scenarios. And we came up with 3 scenarios, and we made somewhat rules for this scenario. So first scenario was, you break your own machine. You take the screwdriver, you open it, you try to do stuff, you look at the API, you try to misconfigure it, and all of a sudden it doesn't brew coffee anymore. Well, we said, we don't care. If somebody does this to his or her machine, we just don't care. And that made the discussion already easier, right? Because there were certain scenarios, we don't care. On the other hand, this meant every single point of data that is on the machine is not secure. And everything that comes from the machine to the other components is not secure. But then, this already shortened the discussion also. Is there a way how somebody can? Now, we just assume somebody can and will change the data on this. Second scenario, you break somebody else's machine. You're on the same Wi-Fi, and I don't know, you misconfigure their favorite drink. You try to brew 5 liters of coffee. I don't know, right? You set the water hardness wrong. This was something we definitely want to avoid, because it's annoying for the users if somebody, comes onto your Wi-Fi and plays around with it. Or think about if the machine is in a library or in a shop, right? And somebody does annoying stuff to that. So every time we had a feature that falls into this scenario, we're like, okay, let's try to make it hard. One of the rules we came up with, as soon as you do something really serious to the machine, for example, setting configuration or setting the password, you have to physically press a button. But then if somebody is in front of your machine, he can just drop the machine as well if he wants to be really annoying, right? Last scenario, you break all the machines. So, and this was the disaster case, right? Just imagine that because the machine gets updates over the internet, over the air, and somebody takes over our server and puts a malformed firmware onto the server, and all the machines download it. Well, actually we quite like the idea of building the first coffee machine botnet in the world. But on the other hand, it could also be that all of a sudden in Germany there are 50,000 bricks in the kitchen and every single user has to take the machine to a shop and it needs to get repaired. So this was the disaster scenario. So all the discussion, all the effort, all the knowledge we had, we put into that one because we really tried to avoid this. So for example, in this case for the software update, we use asynchronous encryption and signatures so we can be very sure, not entirely, that this software update actually is the right one for the machine. As I already pointed out a bit, this was not solving the security discussions at all, but it shortened it, because we could always rely on something. Oh, look, this is scenario 2, right? We need to avoid this. Oh, look, this is scenario 1. We don't care. We just assume it's unsecure. And, well, I'm not the expert in all this, but at least this made me feel a lot more comfortable.
Security and all the other topics that we just talked about are very important topics. I believe strongly that this is the most important, making technology invisible. It's really interesting because we talk about connected devices and we say connection is key. It's all about connection. IoT is connected device, connection is key. At the same time, we don't want to bother about the connectivity. We don't want to care about connection. We just assume, yes, this coffee machine is a high-tech device, but we also want to make sure that it just works. So we had a very interesting moment or an incident in the project. Just imagine this is our project. It's like sails on the sea and it's really calm and it's all really safe. We went through all the struggle with the user flows. We had our little storms. But then we're on the clear sea. We just finished the Wi-Fi setup flow. We're really happy. We're really excited. We're going into user test full of excitement. We just thought we just can make a check mark on the user test for the Wi-Fi setup flow, and everything is just perfect. And what came was our waterfall moment, because it did not work out as we had predicted. Almost nobody who tested our Wi-Fi setup flow did not succeed in connecting the devices. That means nobody was able to establish a connection. The connection we talked about all of the time, all the complicated user flows, all the basis of our entire project, the heart of our entire project, did just not work. People just didn't go in. And those were not, totally tech, people they would never touch the cell phone. And those were young tech-savvy people, and they were not able to make a connection. What a disaster. What a horrible thing. And so, we we failed in this, and we also saved the project, so I can rest assured everything is fine. But it also showed us that it's such a different thing developing for this kind of a device, because we have to make sure that the basic functionality has to be without really thinking about it. We have to make sure that we save the project for all different users. And I made these users especially bland to show that is old and new people or tech-savvy people. There's nerds and hipsters and yuckies and whatever. And they all have to be able to make these connections, because if you cannot make a connection with this, nothing is working. And it was interesting for us because we had to rethink our entire approach, especially also to UI, to UX, to make sure this is a different device. If we're not able to establish this connection, we won't succeed in this entire thing. And we also know that somebody else will do, because if we don't make a good interface, and there are more than enough examples in the tech world, somebody else will, and they will succeed, and they will sell the machines. And we'll still sit there with our machines that are unconnectable. there is one website. There's actually many websites how to connect your wireless device to your network. And I don't know how motivated you are if you buy a new device to like go through a marathon of like annoying YouTube videos with all kind of people and to scroll and to look into whatever, talk to people, look on forums, like get all this like nonsense that is like out in the world, get into your brain just to figure out how to connect your device. I mean, how many machines would you buy from a certain company if you know that it would end up like being in a total nightmare? I have to say, I'm not. I'm totally impatient with that kind of stuff. I would not even like look one video. If that doesn't work, I would not buy it. If I read on whatever on the reference on Amazon that there's problems with the connectivity, I just don't buy it. And this is just like for myself. A coffee machine is a different item than, let's say, an iPad or a computer or whatever, like a program that you buy for your work. A coffee machine is something that everybody has to buy. As we said before, it's an anachronistic thing. It's a coffee. Everybody wants to make a coffee. Everybody wants to, if they buy a machine, they want it that it makes coffee. Easy, unproblematic, like without anything to this. So I always imagine I have to give it to my dad, I have to give it to my grandma, and they still have to make it work. And there was really like a different thing. So we took out of this, we had to rework a lot, we reworked a lot, but we also saw how important it is to make it really easy for everybody to use. Therefore, making technology invisible, although it is a high-tech machine, that is at the core. When we talked about prototyping and testing and all the stuff that we've talked about it, if we're not able to make a connection, we can scrap all of that. We don't even have to stand here, we don't even have to give this talk. But luckily for all of us, also luckily for you, we fixed it and everything works.
This is already wrapping up. So the title of this talk was 50,000 lines of code for a cup of coffee, and this is how we spent them, right? We built prototypes to fake the hardware. We tested a lot of things so everything works smoothly together. We tried to get this stupid thing connected. We tried to avoid the security disasters at least, and we wrote lots of code to hide the technology about it. And those are the 5 points. The next time I'm going to have a new project that somewhat has a connected device in it, I will definitely look at those things again and first and plan ahead. And I'm sure I will save a lot of time on this. So hopefully, just watch this slide, and the next project comes, pull this slide again, and discuss those things early. While we were working on this project, we were coding for a week, and after a week you step back a bit and you look like, what did I do this week? And when you then look at the time you spend on features that are actually user-facing, compared to the time you spend for all the rest, just to make everything work, that was quite frustrating, honestly. I know other projects are like that as well, but for me, the ratio was way worse than it used to be in other projects. So if somebody asks me now, how does IoT or connected devices change the way we work as a developer? I must say not that much, right? Because all the things you learn, you still can apply them to that. They will become more complex, they will become longer, they will become more tedious. But just because you can't automate all the tests 100%, don't throw the methods you do out of the window. Just push real hard to apply them at least a bit. And at the end then, well, this picture is from when we brewed the first coffee, right? And not only the team, but almost the entire office gathered around the machine. And look at the different faces. There's excitement, there's anger, there's skepsis, right? And look at the Herman on the very, very left, right? He's praying. He's praying like, let this thing explode. So at the end, it was really fun because we finally built something tangible, something that builds, smells like coffee. So with all the complexity and all the tediness, it was really fun. Thank you. So we have time for some questions. What are your questions? And I'm going to walk around with the mic.
There's one question on Speaker Brain. Someone's asking about the connectivity module, and he's asking if it's reusable for other IoT projects.
Very good question, because there are things like It was called before Spark IO, I guess. So it's a little device you can buy for a couple of dollars that magically just connects to backend services. So all this stuff, all the effort we had to put into getting this, you can buy stuff. However, all the methods you can think about, WPS, near field, or things like Spark, was not really working for us because we wanted this mode where you just plug in the machine and it's not connected, right? So there are other things and you have to verify all the methods there are if you start a project. For us, we had to go the tedious path. And I would assume I can't reuse much of it for the next one.
You talked about the guided manual testing. Did you have any problems with the testers becoming bored and maybe just don't follow the instructions really thoroughly? And how did you cope with that?
So we had a tester on our team, and he was really into that, right? And honestly, we did not receive an update that often. So we are talking about every other week. So I guess if you have to do it every day, you won't do it. And then probably you need to find other layers of testing and maybe have very little on top of those.
Okay, another question through the app. How do you fix the password provisioning problem?
Password provisioning problem. I'm not really sure about this, but, well, at some point you have to give the machine your password, right? And because it needs to connect to the Wi-Fi. And so we just did secure connections to send the password to the Wi-Fi. And yes, it's stored then on the machine because it has to know it. If somebody reads out the memory, he or she knows the password. On the other end, this person is in your Wi-Fi with a screwdriver in front of the machine and opens it. So we made sure that the connection when we sent the password is secure. Don't know if that answers, but maybe this person who asked the question can come to me later. I guess that's it then.
We forgot one crucial part. We should have had like a first slide and a last slide from the conference. So we totally forgot that. We messed it up. On the last slide, there would have been like, please fill in the voting or something like this. Please vote on some tool. We also forgot that. So please now as a oral motivation for you, please do this since we forgot it in the slides.
Thank you.